Now this problem is related to acid catalyzed dehydration. So this is we have 2,2-dimethyl 1-cyclohexanol. So this molecule 2,2-dimethyl 1-cyclohexanol upon dehydration this gives isomeric alkenes, and one of the alkene that is 2-methyl 2-heptene this molecule. So you see this is 1 2 3 4 5 6 7 heptene, and this is position number 2 there is you have ene, so 2 heptane, and position number 2 you have methyl group, so this is 2 methyl 2 heptene. So one of the molecule that is here. Now the question says write a step-wise mechanism for this formation. So how will you form this compound using this one? So let us try first. What I will do is let us put this as a R. So I can write this molecule because it's a big molecule. I can write R, and I have CH3, and there I have CH3 and then CH2, and then I have OH. Now H2SO4 basically will give H plus. So let us write down the mechanism. You will have RCCH3 CH3, and then you have OH2 plus. Now in the next step you can lose this one and then you can make a carbocation here. Are you getting or no? This is CH2. I have left this CH2. There is a CH2 basically you have, and then you have OH2 plus. Now in the next step you can lose this, and then in the one step if you lose this H2O, at the same time you will have a primary carbocation. Generally primary carbocation is not very stable, so same point of time you can migrate this methyl group here. Are you getting? So this is a methyl shift. So you have RCH3 and there you have CH2CH3, and there is a positive charge you have, and now I can write what is R. R contains 4 carbon, so R is basically CH3 CH2 3, and this is 4 carbon, and this CH3 plus charge, and then you have CH2 CH3. Now you can have two alkene, that is possible. So if you lose H plus from this side you will get one alkene, you lose H plus from this side another alkene, you lose H plus from this side. So there are three possibilities. You can write these three possibilities basically. So let me write. So this is CH3 CH2 CH2 CH. Let us make bond this side, and this is CH2 CH3. Another possibility from this side. So this side you have 4 carbon, 1 2 3, and this is 4. So you have 4 carbon here. Now another possibility from this side. So you have CH3 CH2, now this side will have CH2 CH3. So there are three possibility will have. Now this will also exist as a cis trans isomer, so you will have cis as well as trans both for this compound. Now this will have only one isomer. This also exists as a cis as well as trans both. So this also has cis trans isomerism. So basically a mixture of alkenes. So you are getting a mixture of alkene. And this is basically your B part of the question, says what other alkene do you think to form during this reaction? These are the alkene that is formed during the reactions. Now but still I have not formed this alkene. You see this alkene we have not formed, that is the 2, this molecule 2,2-dimethyl. So it does not have any such kind of molecule. This means I should have a 1 carbon and then we have 2 CH3 4 kind of thing. So it does not have this alkene. So even though we have formed a lot of alkene, we have not formed the real alkene that we have to form. So what can you do? If you think here you can, if you migrate R group, there is maybe possibility then you can generate that alkene. So let us try that one. So you have R, and then you have CCH3 CH3, and then you have CH2 plus OH2 plus at the same point of time. When this group goes here and this groups migrate here, so this time alkyl migration. So this is not a methyl migration, this is another alkyl group. Alkyl group migrates, So I will have something like this. One arrow is enough. Now this carbon will contain positive charge, and here you have CH2R, and R is basically 4 carbon, CH2, 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 and then CH3, and it is positive charge. Now you have two options: either you can make a double bond this side, or you can make a double bond this side. So you will have CH3, C double bond CH2. I can make a double bond and then write CH2, CH2. Now I will have 5 carbon because one carbon, this is also there. 4, 5. Now this molecule is the same molecule. You see, this is 1, and this is 2, this is 3, 4, 5, 6, 7. You see, this is the same molecule. So you have, no, this is not the same molecule, this is a different molecule. Now if you lose from here, this side, you will get the same molecule. So if you lose H plus from this side, you will have CCH3, CH3 double bond, and you have CH, and then you have 4 carbon, 1, 2, 3, 4. So there are 4 carbon you have. So this molecule you will have. Are you getting? So this is the 2,2-dimethyl 1-hexanol. So this is 2,2-dimethyl. You have 1, 2, and this is 2,2-dimethyl, not 2,2-dimethyl. This is only, oh, this molecule is not 2,2-dimethyl. This is 2-methyl 2-heptene. Are you getting or not? So this is 2-methyl 2-heptene. So you see, this is the 2-methyl 2-heptene. So this is 2-methyl and 2-heptene. And whether you have got this mix this a new alkene, or we have already got this one. So let us check this one. So I will have CH3 and double bond. Again, this is again new molecule. So this molecule is a new molecule. So you see, there are 4 molecules. This one is 1. This is second. This is third. And this one is fourth. And this one is fifth. So there are 5 alkenes possible, and cis trans isomerism are also there. So there are 5 isomeric alkenes are possible. So 5 isomeric alkenes are possible, excluding the cis trans isomers.